Hello everyone, this is Meena teacher from Mathsmisfit. Today's topic is Indices and Surds. We'll be doing the first part of this, that is the basic concepts, the properties and laws, and a few simple examples based on these. All these will be helpful for all your competitive exams, maybe of the banks or UPSC or IBPS, anything. Okay, so as a revision, let's do something about index numbers. You have done in your school days a raised to n, which is nothing but a multiplied n times, and it is written as a raised to n. The real number a is the base and n is called the index number or the exponent. Now I have taken an example 2 into 2 into 2 10 times, which is written as 2 raised to 10. Now surds, let a be any rational number and n be a positive integer such that a raised to 1 upon n is nothing but nth root of a, and nth root of a is irrational. This is called as a surd. N is called as the order of the surd. Now I've given 3 examples down. The orders are 3, 10 and 5 respectively. Now coming to the laws and properties of indices. The first law is called as the multiplication law. A raised to m into a raised to n is nothing but a raised to m plus n. The next property, instead of the multiplication, we have a division. So the index numbers are subtracted. Any number raised to 0 is 1. Very important property. A negative, a raised to minus n is nothing but 1 upon a raised to n, which is taken as the reciprocal. A raised to m, the whole bracket raised to n, the index numbers m and n are multiplied. AB raised to n is nothing but individually each a raised to n into b raised to n. Instead of a multiplication, we have a division. A upon b raised to n is nothing but a raised to n upon b raised to n. The laws and properties of surds. The first one, nth root of a is nothing but a raised to 1 upon n. Nth root of ab is nothing but nth root of a into nth root of b. Instead of a multiplication, you have a division. So nth root of a upon b is nothing but nth root of a divided by nth root of b. Nth root of a, the whole thing raised to n, is nothing but a. I've given an example there, that is 5th root of 10, the whole thing raised to 5 is nothing but 10. Nth root of a is nothing but mnth root of a. That means m and n have to be multiplied. Nth root of a, the whole thing raised to m. This becomes nth root of a raised to m. Now a very important point that you need to note. Under root a plus b is not equal to under root a plus b. Now I've given an example there. It is applicable for addition as well as subtraction. Multiplication. For multiplication, we follow all the algebraic rules. So first example that I have taken, just open out the bracket. 4 cube root 5 plus 4 threes are 12. The second one, again, 7 5s are 35, but cube root 5 will remain as it is. Second part, 7 7s are 49 and under root 7 remains the same. The next example, when we open out the brackets, 7 3s are 21 and the root 7 will remain as it is, and 7 into root 3, that will become under root 21. All right. So what I have done here is that the roots are multiplied, that is 7 and 3. Now take the next example. There are two brackets given and we need to open out these brackets. So we follow the rules, simple rules of algebra. What we do here is like what we do in algebra. We take the first number, that is 2, and multiply by the second bracket. And we do the same thing. The second number multiplied by the second bracket. Open out these brackets and you'll see that we come to 2 root 7, 2 root 3 and root 21. Now these are all unlike. What would be the like terms? The like terms would be something like this. 2 root 3 plus maybe 3 root 3 and minus 2 root 3. So you'll see that they are all root 3. So 1 plus 3, 4. Final answer will be 2 root 3. Alright. Now over here, it's a bracket raised to square. So we'll use our formula of a plus b the whole bracket square. And you'll see that once we open out the bracket, we get a final answer. Just follow the simple rules and simple formulas of algebra wherever required. For division by a monomial, it's very easy. So if you take the first part, that is 2 root 14 divided by 2 root, we can put it very simply like this, 2 root 14 divided by 2 root 7. So the 2 and 2 cancels and this would become root 14 upon root 7, which is nothing but root 2. Okay. Now if you take the second term, it is 6 root 7 upon 2 root 7. Root 7 goes and you're just left with 3. So your final answer would be root 2 plus 3. But when we have to divide by a binomial, then we have to use a rationalizing factor. Now the rationalizing factor for the denominator. In other words, we need to bring this irrational number to a rational number. So we multiply and divide by the conjugate. Now what is the conjugate? If you look at what I have written in red, I have just changed the sign of the denominator. From plus, I have made it minus. So just multiply and divide by this. And then numerator, open out the brackets. In the denominator, we have used the property, our algebra property of a plus b and a minus b. This is nothing but a square minus b square. So if you see here, what we get is the denominator as a rational number. All right. Now coming to our problems that we are going to solve using these. Simple problems are there. what is given to me, I can write it as 0.2 the whole thing raised to 5. And then it is multiplied by 3 upon 5 in the index number. So this comes out to be 0.2 the whole thing raised to 3, which I can write as 1 upon 5 raised to 3. And this is nothing but, so a correct answer here is the D option. The second sum, I can write this as 10 raised to 3 and the whole thing is again raised to 12 divided by 10 raised to 3. So this will become 10 raised to 36. Now the division law that we are going to use is a raised to m upon a raised to n is nothing but a raised to m minus n. That is the law that we have used. So we get this as 10 raised to 6. Now if you look at your options, you don't have this as an option, but I can convert this and write it as 1000 square. So my correct answer is going to be the A option here. 256 can be converted to the power of 16. It is nothing but 16 square into 0.16 into 16 raised to 0.18. Now I have the bases as the same and a multiplication. So I can use the law. This would be 32, 0.32 plus 0.18. And this comes out to be. Now, the 16 raised to 0.5, I can convert the 16 as 4 raised to 2 into 0.5, which is nothing but 4 raised to 1. And final answer is 4. So option C is going to be the correct answer. Very careful you have to be with this type of sums. If you look at what is given to you, there is a plus sign over here. So we cannot use our multiplication law. Have a look at what I'm going to do here. This is 2 raised to x minus 1 plus. I am going to make this also. I have deliberately got this to the power which is like the first term. And we'll see why we have done this. So this can be written as 2 raised to x minus 1. Now over here minus 1 plus 1, I have not changed anything. So this becomes 2 raised to x minus 1 and this will be 2 raised to 2. This comes from here. So if you look at this, I have 2 raised to x minus 1 common in both the terms. Now remember, when there is a plus and minus, you have to do something by taking out something common. And 2 raised to 2 is nothing but 4. So I have 2 raised to x minus 1 equal to 1280 divided by 5. 6. Now if you look at this number 256 and if you look at the base here, what we can do is we can bring this to the same base. So what is 256? 256 is nothing but 2 raised to 8. and bases are the same. So my index numbers are going to be equal, and I'll get x equal to 9. Okay, what we have done in this step here is we have got the bases the same. So index numbers will be equal, and a correct option is the A option. This is a very simple sum. If you look at this sum, now here both the bases are the same, but again there is a plus sign. So let's see what we can do. 16 can be written as 2 raised to 4 into 3 by 2, plus I'll do the same thing here. So this will be 2 raised to 6 plus 2 raised to minus 6, which I can write it as 2 raised to 6 plus 1 upon 2 raised to 6. Now the property that we have used here is this one. A raised to minus x equal to 1 upon a raised to n. 2 raised to 6, that is 264 plus 1 upon 64. You can calculate this and get your answer. It is 4097 upon 64. So your correct option will be the B option. Now here we have multiplication and division only. So this is a relatively easier sum. 243 can be written as 3 raised to 5, and then this is multiplied by n upon 5. This is already the base 3. Nine can be written as 3 raised to 2. Now you'll see, this is a very simply a problem where you have to apply your product property. So 3 raised to n, 5 goes. So this will be n plus 2n plus 1. Everything which is in the denominator, the index numbers get subtracted. So I have a plus 2n minus 2n plus n, and I'm left with 3 raised to 2, which is nothing but 9. So a correct option is the C option. Again, this is a relatively easier sum because all the bases are the same. So first thing is open out the brackets. So this will be 2a plus 2b into x raised to 2b plus 2c into x raised to 2c plus 2a. The whole thing divided by, now there is a 4 outside. So this will be 4a, 4b and a 4c. Now you'll see all the bases are the same. That is x. So use your property. All the numerators you can add. And the denominators you will subtract. And finally, what you're left with is x raised to 0, which is nothing but 1. Any number raised to 0 is 1. That's the property that we have already done. So your final answer in this case would be the D option. When you look at this sum, the LHS and RHS reciprocals of each other the bases are. So I am going to make the bases the same. And the reason for that is once the bases are same, I can equate the index numbers. So I'm going to do this on my RHS. I'm going to make this as P upon Q. So this will become negative Px minus Q. Property that we are using, a raised to minus n is nothing but a raised to n. Now my bases are the same in both the cases, that is in your LHS and in the RHS. So what will happen to the index numbers? They would become equal. I need to find the value of x, so I'll take the terms of x together. Take out x common. Sorry, this is n plus p. And x would be s plus q upon n plus p. Look at your options. The fourth option, that is option number D, is going to be the correct one. You have got two equations given to you. So I'm taking the first equation. 8 I'm going to convert to 2 raised to 3x multiplied by 2 raised to y is equal to 512. Now the bases are the same here. This I can write it as 2 raised to 9. So I'll get 2 raised to 3x plus y equal to 2 raised to 9. Now bases are the same, so I'll get a first equation here. Now I'll take the second equation. 3 raised to 3x plus 2y. I can make this as 3 raised to 2, 6. So this will become 3 raised to 12. Now the bases here are the same. So I'll get a second equation from the second, I'll get a second equation now here in x and y. Alright, solve these simultaneously. So I'll put 3x plus y equal to 9, subtract, and you'll get your answer. Y is equal to 3. You look at your options, you need not even calculate x because in the 4 options, the second value is only for the B one. So our B option is going to be the right option. This is an interesting sum, little tricky, and be careful. We have got a minus sign in the numerator. So what I'm going to do is, first thing, 2 raised to n plus 4 minus 2 raised to n. I'll leave it as it is. Sorry, this is 2 into 2 raised to n. Denominator 2 raised to 1 plus n plus 3. Bases are the same in the denominator. So this becomes 2 raised to n plus 4. I'm separating out the terms here. Numerator, this will become 2 raised to n plus 1 because this is a 1 here. And denominator is 2 raised to n plus 4. So this cancels and I have 1 minus. Now here the bases are the same. So using the property, this is division. So this would become subtraction. So this would become 1 minus n cancels, 2 raised to minus 3, which is nothing but 1 minus, using our property again. So this would become 1 minus 1 upon 8 and your final answer would be 7 upon 8. And your correct option from here is the D option. If you look at your right hand side, the base is 0.2 raised to x. So let's get everything on our LHS to 0.2. This I can write as 0.2 the whole square, which is again a square, divided by 8 can be written as 0.2 whole bracket cube, and this is already in 0.2 raised to 6. Alright, so now everything is on your LHS has been converted to the base 0.2. So this would be 4. There is a division, so this becomes a minus. Multiplication, this would become plus. And now here the bases are the same. So index numbers are going to be equal. So x will be equal to 7. So our D option is going to be the correct one. Similar sum, let's see what we can do here now. 2 raised to n minus 1 minus, I'm going to make this also minus 1, so I get a plus 1. And denominator 2 raised to n plus 4. I can split up this 4 as 1 plus 3 plus 2 raised to n plus 1. Like we did in the previous sum, I'm going to take out 2 raised to n minus 1 common. So I'm left with 1 minus 2 raised to 1 upon. In the next step, I am going to take out 2 raised to n plus 1 common. So I'm left with 2 raised to 3 plus 1. So using my laws over here, this will become 2 raised to n minus 1 minus n minus 1. This is only for this part over here. And 1 minus 2. So this would become minus 1. 2 raised to 3 is 8 plus 1. So this would become 9. Over here, this goes. And I'm left with 2 raised to minus 2 into minus 1 upon 9. Now 2 raised to minus 2 is 2 raised to 2 into, answer is minus 1 upon 36. Okay. See the important step that I have done. That is, first thing that I have done is I have split up that numerator. The numerator value of n. And very conveniently I have done it so that I can get n minus 1, which can be taken out common in the next step. That is over here, and a similar thing we have done in the denominator. All right. A similar sum again. So 2 raised to 2x minus 1 plus this would become 2 raised to 2x. 2 raised to x minus half. Over here, I'm going to make this like this. That means what I have done here, minus half plus half anyways remains the same as plus half. In the next step, 2 raised to 2x minus 1. For this, I'm going to write 2 raised to 2x minus 1 plus 1. That is over here that I have split up. And here, I'm going to take 2 raised to x minus half common, and I'll be left with 1 plus 2. Here, I'm going to take 2 raised to 2x minus 1 common, and I'll be left with 1 plus 2. So you see what we have got now here. This is into 3, so this and this will go. Now our bases are the same, that is 2 here and 2 here. So we are going to equate the index numbers. And you'll get your answer as x is equal to half. Correct option in this case is the A. So we have done about 2-3 sums where we have got a plus or a minus, though the bases are not the same. Even if the bases were the same and there was a plus minus, we cannot use the law of addition or subtraction. A very simple sum. 32 can be written as 2 raised to 5. This is 10 raised to, this will be 2 raised to 5 raised to 2. 10 raised to minus 10. I have directly opened out the brackets, and this will be 2 raised to 6. 2 raised to 16 into 10 raised to minus 4, and this is equal to 10 raised to minus 4. Now I have got 3 terms which are of the same base, 1, 2 and 3, and I have got 2 other terms, that is the ones with the 10 and 10. Okay, so let's take the ones with the same basis together. Numerator, and I'll subtract the one from the denominator. So this becomes 2 raised to 0 into 10 raised to minus 6. Now this is all given to you equal to 10 raised to x. So equating the index numbers, we'll get x is equal to minus 6, since the bases here are the same. This anyways will become equal to 1. So our option over here is going to be the D option. What I have taken are a few examples. I have not done anything of surds in this video. The problems of surds will be done in the next video. Don't forget to like, subscribe and share. Share with your friends so that they also benefit from all that I am doing. Okay, see you in my next video. Bye. Do take care of yourself.